Dear student, in this lecture, we are going to study another very important concept, object orientation. In today's lecture, we will study what is object orientation and why it is important in programming and what are some advantages of using the object orientation approach. Now, before introducing the object orientation concepts, I will set up a background about object orientation. In the section of data structures, we learned that how we can store a bunch of things together in a collection called list. Same is the case with the dictionary and tuple data structure. Now, what is the advantage of doing so? Because it is easy to manage things like insertion, deletion, etc. Moreover, it is easy to use this same list anywhere in your program, or you can use this list in the other programs. And this was the one layer of abstraction that we studied. That is, collecting all the things together in a single data structure called list. Then we study another layer of abstraction called functions. We write the program in terms of mini programs called functions. In this figure, F1, F2, F3 and F4 are functions and they contain their own code. There are several advantages of writing a program in terms of functions or mini programs. For example, your program becomes modular or divided into the logical units which are easier to understand. And the other advantage is reusability. You can call any functions anywhere in your program as many times as you can. Apart from the advantages, there are several disadvantages of using the functions. For example, functions are less reusable in other programs. For example, if you want to reuse a function that you have written somewhere else and now you want to use that function in your own program, then it becomes very difficult for you to migrate that functions from old program to your new program. Now let me explain this with the help of example. Many functions that you write are dependent on some global data for functioning. For example, in the previous project of tic-tac-toe game, our function showboard was dependent on the list data structure. So, functions are dependent on the global data that you use in the program. So, you cannot migrate a function to another program because they are heavily dependent on the global data of that program. Moreover, a function can call another function in the same program. In this case, it becomes difficult to reuse that function. Instead, we need to reuse function 2 f2 with f4 together. So, we need a kind of collection where we can migrate both data and functions together. So, in order to avoid this problem, it is better to use classes, which is another important concept in the object orientation. So, a class is another layer of abstraction that contains both data and functions. You can also call data as properties or functions as behaviors. Now coming back to the question, what is object orientation? So object orientation is the technique for system modeling. Another question is, what is system? A system is a set of things working together as parts of a mechanism or an interconnecting network. And the same concept has been represented in the second part of that definition. OO model or object-oriented model consists of several interacting objects. Now let me give you an example of object orientation. Now consider the example of snooker computer game. The snooker game is one example of a system. You already know that a snooker game consists of several objects like player, football, ground, audience, referee, scoreboard, or many more. These are all objects and they interact with each other to perform some useful activity. A snooker game is an example of a system and all these objects are part of that system and they interact with each other to perform some useful activity. Now what is meant by interaction? What do you think What is the interaction between the player and football? Of course, a player can hit the football. So this is one interaction. Now, what is the relationship between the referee and player? Of course, a referee can direct or control the players, and audience can watch players, football, referee, ground, etc. And what is the interaction of the ground with other objects? Of course, a ground can contain all of these objects. So, in simple words, every object has some interaction or relationship with the other object in the system. Now, the question is how one object can interact with the other object. The answer to this question is through messages. Objects in a system communicate with each other through messages. The sender object needs to call and appropriate operations on the receiver object. This is how objects can communicate in a system. So, what is modeling? If you can represent all of the objects in a system and you can also represent the relationship between those objects in a system, then it becomes the model. Have you seen a small toy aircraft when you are a child? A toy aircraft represents the model for the actual aircraft. It is the representation of reality, but it's not a reality. So, object orientation is a technique of system modeling, and a system comprises of several objects that interact with each other to perform some useful activity. And if you can represent all of the objects in your system and their relationships in some diagrammatical way, then this is called modeling. Or you can say object-oriented model. Now think of other examples. Think about your class. Your class is a system. And how many objects it contains? There are many. For example, a teacher is an object, student is an object, whiteboard is an object, multimedia is an object, and there are some other objects as well. And these all objects have some relationship with each other. For example, teacher teaches the student, and teacher uses multimedia and whiteboard to guide the students. Now there are several advantages of using the object orientation. The one is people think in terms of objects. Now look at this example. It was easier to identify these objects instead of functions. Have you seen any functions there? Of course no. So functions are something which are hidden inside of these objects. For example, look at the player object. What kind of functions or behaviors a player has? For example, he can hit the ball, he can run. And what is the functionalities of football? Football can move. What is the function of audience? They can watch. What is the function of referee? He can direct the players. What is the functionality of scoreboard? It gets updated whenever a player hit a goal. And what is the functionality of a ground? It can show all of these objects. Apart from the functions, they can also contain the data or properties. For example, what is the data associated with the player object? Of course, it should have some name, age, gender, weight, height, etc. And what is the property or data of this football? It has weight and diameter. What is the data of this scoreboard? Of course, it has a score. So, objects contains both data and functions together. In the list data structure that we studied earlier, list only contains data, but object contain both data and functions together. Now coming back to the first advantage of object orientation, people think in terms of objects. I think it makes sense now. Object-oriented models map to reality. This is very obvious as you have seen in the snooker game. Therefore, object-oriented models are easy to develop and easy to understand. I hope you understand this lecture. In the next lecture, I will describe the difference between the class and objects in detail. Thank you for watching.